for this tsunami project, we do not have a very good geodatabase. And one of the reasons is we didn't have a schema or a plan before we started. Things just kind of got added. And sometimes it's really hard to develop a geodatabase, a really good one, until you've figured out what you need. And so one of the industry needs is for people to go into historic data and create a geodatabase and put it together. And so a couple years ago, one of their students worked for the Siuslaw watershed and took their hundreds and hundreds of shape files with incorrect projections and data and put it all into a really nice geodatabase schema. And we have I'll show you that. It's really lovely, but it was a huge job. It's a huge job. He did. He got a paid internship, a co-op for that. Yeah, that was very nice. So we're going to talk about the tuna can. So we're going to talk about geodatabases, and I added a, hey Pam, I added a PDF called something 9 Reasons to Use a Feature or a File Geodatabase. I found that online. I thought that was helpful. So basically a geodatabase stores spatial data in tables, feature classes, feature data sets, rasters, tables, all kinds of stuff. And it's really, it's what people are doing now, although there's still a use for shapefile. So one reason is it's an automatic compression folder that keeps all your data together. It will also store topology, like a coverage. Shapefiles don't have topology, coverages do, and a geodatabase will have aspects that you can store that. So the other very cool thing is data that's in a geodatabase, if I cut the polygon in half, it automatically recalculates the area, the perimeter, so you don't have to keep doing that. That happens automatically. It's supposedly difficult to corrupt your data in a geodatabase, although it has been done. And it just helps kind of your overall data organization. And a lot of people do not use them. And a lot of reasons for that. But anyway, so when you look in our catalog, the file geodatabase and the personal geodatabase look the same as far as the icon. It looks like the tuna can. So you can't really tell just looking at that shape whether you have a file geodatabase or a personal geodatabase. The suffix tells you, right? The file type, GDB or MDB. And when you look at it in Explorer, they have different icons. So the personal geodatabase is run on Access, and so it has that little Access icon. And a file geodatabase just looks like a regular folder, right? So that's one way if you're opening up, your flash drive and you're looking in your files. That's one way you can tell whether you've worked in a file or a feature data, or file or personal geodatabase. So the nice little diagram showing the different capacities. So basically a personal geodatabase, maximum you can put in there is 2 gigabytes. And for a lot of the price projects, 2 gigabytes is fine. But once we start working with a lot of raster data or LiDAR data, 2 gigabytes is not enough anymore. And the file geodatabase lets you hold 1 terabyte per table. So these can be really big, yeah. And then the multiple user or the SDE or enterprise geodatabases, those are kind of the big dogs. They run Oracle or MySQL, and they can hold, they can hold the world's data, I guess, on there. All right. I'll go over that just a little bit more. So the Enterprise Geodatabase, SDE, those are multi-user platforms, so that if I had, we had a class last year that was set up with an SDE site, and so all of the students were all editing the data at the same time. And it would keep versions. So if Nathan made an edit, it would record that, and Brian could come in and look at Nathan's edit. They could be editing the same feature at the same time. It would have a timestamp so you'd know whose was the latest, and it would keep all of those, and then you could keep the ones that you wanted. So very high level corporation, large data sets, not the kind of stuff small shops use. You have to have ArcInfo or ArcEditor to run an enterprise geodatabase, and those are the more expensive packages. And so small businesses or small companies are probably just running, gosh, ArcEditor used to be the little one. I can't remember what the lower version is, but they're probably running a lower version or an older version that doesn't let you do the big, and they probably don't have a need for the big database management. Yeah, Ryan?
Can we not use a personal database if we're running ArcGIS on Linux?
Yeah, you can. Yeah, that will run on Linux. The personal geodatabase will only run on Windows. Okay, so that's yeah.
See, by default, then it's kind of a better idea to use file.
That's what I do. I just use a file because I know I can share it. It'll open in other GIS programs, you know, and the personal is pretty limited.
So what's the benefit of a personal over a file?
Less space. Yeah. If you don't have a lot of room on a flash drive or on her DVD, she doesn't have a lot of room. But also, they were the original. The others have come after. So a lot of the data that we're seeing in the price is from version 8 when that's all they had. Right? That was, I think, the first time they had a geodatabase. And then you'll see some are file geodatabases. If you were using price 4, there were no file geodatabase. Everything is in a personal geodatabase. So that's why you see some mixes. And she just hasn't updated stuff as she's gone.
Everything we work with, we might as well use the file geodatabase.
That's what I use. I just recommend the file. Yeah. Okay. All right. With SDE, as I said, you can have multiple editors. You can edit over long time periods. It'll archive, and you get a lot of data replication. In a personal or a file geodatabase, ideal for like a single person, small groups. I think I already said how much space is available. You can have lots of people go in and read your data, but only one person can edit at a time. Okay, so they automatically put a schema lock, and you may see that at the bottom of your computer sometimes, or it'll create a temporary schema lock file that you'll see, and that means somebody's editing, nobody else can edit in here. Yeah. Okay. Yeah. Okay, so Windows only access. The personal geodatabase, even though it says it's limited to 2 gigabytes, it will slow down like dramatically when you're only 1 gigabyte full. So it really has, the function decreases. And so that's the other reason that I just use the file geodatabase. So when we're creating a geodatabase, one of the things that you'll see inside a geodatabase are these structures called feature data sets. We worked with those a lot last term. And each feature data set should have related features in it, right? So we kind of have just created one feature data set and put everything in it. This was easy. We were learning how to do that. But if we were creating one to look at, let's say, Lane County transportation and what is this, utilities, we would have different feature data sets set up for the utility data, and the road data would have another one, and the water networks would have another one. So you'll see that as you look, when you get ready to do the geodatabase exercise, you're going to have different feature data sets set up for specific pieces of your data. It will also set up a topology. So here's an example of a feature data set that is the topology, and it takes the boundaries of Iran and the annotations, which are the labels, and puts all of those together with this topology that enforces those lines that they say coincident. one of the real benefits of a geodatabase is to be able to set up these things called domains, attribute domains. And an attribute domain is really useful for data collection so that I don't have to type the word. What were you typing in there? The type of the line, dashed or solid, every time, right? What it does is create a drop-down list, and I can just click, okay, this one's dashed, this one's solid. So it eliminates typos. And one of the things, when we get to the earthquake data, you're going to see that there are earthquake hazard types that are identified as high for high potential, capital M for medium potential, low M for, I think somebody forgot to make it a capital M, and then L for low, right? And so if they had coded those domains, you couldn't type in a lowercase m. It would be whatever you set that for. So it keeps you from having errors. So that kind of the idea of ensuring the integrity of your attribute data, right? So it's really good. You can set value ranges. So let's say when you are creating culverts, you're digitizing where culverts are, and you only have 4 diameters of culverts. You don't have to type that in every time. You can say, okay, I can only use these 4 culvert diameters, and you don't get somebody actually typing 500 instead of 50, right? So it helps with that. And then you can do these coded values. So we'll set up all of those. So I think you'll set up several different types of domains when you work on your what am I talking about? Blah, blah, blah. Where was I go? I just trying to record this and not actually have it move that way is. Okay, there's that. I think I skipped a slide. That's what I did. Okay. That's why I'm confused. How did I get there already? Okay. I skipped that. Yeah. Okay, so let me go back. So if you open up the Geodatabase, this is kind of from Price Chapter 1. You see the feature data set. You see all of the feature classes that could be in a feature data set. You see these relationship classes. So if you have data that has relationship joins, you can use those. So I can relate to tables, and you'll see that in your Geodatabase. If you make tools, and we did that, or you do a model builder, all of those things can be in your Geodatabase. Oh, now I'm back on track. Okay. So it also helps you can set up rules so that when you split a polygon, it knows to automatically recalculate the geometry and maybe the value field. So maybe if I have a piece of property that's worth $1 million and I cut it in half, I'm going to say, take those values and divide it by the ratio. Or I could set up other values. With the merge features, so let's say I buy 2 parcels of land and I merge them into one. I can sum up the values. So I can set up all these things ahead of time that really are labor savers. Okay. And then within the feature classes, you can set up subtypes, and that's what we were talking about. So if I say I have water lines as one of my feature classes, and then I could set up different types of water lines. Is it a main water line? Is it a lateral? And then I could set up the values for each of those. So you can see that I can add a lot of detail into my Geodatabase that would set up much easier process of editing and creating and collecting data. Okay. And we can set up those relationships. So when you're looking at tax lots, you could have a one-to-many. So one person can have many parcels of land. And those are easy. If I die and my land goes to somebody else, that's easy to update those relationships. You don't have to find every one of my parcels because they're already, if I die, when I know it's going to happen. Anyway, I know people always say if I die, like, they know something I don't know. Okay, All right. Annotations are great because those set up those text graphics that are linked. They can have scales that change as you zoom in and out. It can also store arrows, flowchart arrows, all those kinds of extra pieces that will also change with your map store or map resolution. So one of the things you want to do if you're ever asked to set up a geodatabase is to think about the schema. And the schema is just the database outline. So I'm going to open this. So this is the USGS schema. Oh, it's not going to show up all that well. I can shrink it down here. Okay, so this is their data model. That's the other term you'll find it under is the data model. So this is the National Park Geology Data Model. And they talk about basically kind of how it started out. But in order to create a good schema, you have to think about every feature that you want to collect or capture in your data, and then all of the subtypes of that feature, and then all of the values that you may have of those subtypes. And so it takes a lot of planning ahead to kind of think about what you would need. So if you look at, let me see, and then you've got to think about the type of data. Do you want it to be an integer? Do you want it to be text? How many characters do you need that? All of that planning needs to go in to your data, and that's why they talk about migrating, because I think these things start out as shape files and then end up changing over time. So here's kind of looking at the geologic unit. They wanted those as polygons. The subunits are polygons, the surface contacts, the volcanic ash units. This goes on and on, all of the different ideas. And then they kind of set up, okay, what are going to be my feature data sets and what's going to be in that feature data set. So there's a lot of planning that goes into creating a geodatabase, and a data model. Is this one the marine one? Let me see if that will open up. Oh, no, this is the Esri, gives you an overview of the utility network. And what's really nice is you can download data models from Esri that are kind of structured and have a basic format to them. So they've got, for somebody who's developing a utility model, here are the general feature classes, features, and domains that are typically used. Somebody who's doing a watershed project or doing a watershed study, here's the general types of things. And you can change it, but they give you kind of a pattern or a plan to start with. Okay, where's the other? And so here is the marine model, and you really can't see it that well, but it lists all the different layers and how they're related, and if you expanded that geodatabase, this is what that would look like. And I tried to find the PDF from this, but it's gone. So the idea then is when you plan your schema, you need to figure out, how you want your data to be stored. Do you need a SDE? Can you use a file? Does everybody want to use the personal because you're all on Windows and it's really small? Then you've got to identify what are your features. What are the feature data sets that would hold those features, kind of your hierarchy of data. Some of that, and your domains and your subtypes. You can change it later, but then it gets really tricky sometimes. And so along with that, you should probably start a data dictionary where you have a list of all the data that you're going to have and what's in that data. And then the general workflow that you'll go through in the tutorial is you'll create a geodatabase. And then she's going to have you create a feature data set with whatever projection you want to use. And then you're going to create some empty feature classes. And you might even add a couple feature classes that exist to your feature data set. And so then once you get your feature classes set up, you're going to go back to your GeoDatabase and you're going to create the domains and the values, and then you're going to go back to your feature class and create the subtypes and point to the domains. So you might want to just kind of print that out, and as you go through price, be thinking, oh yeah, this is what she's having us do. And you're going to set up several feature classes and domains for different feature classes as you go through the project. So one of the things that I posted the other night was just a question on, was a forum. Let me see if I can get this up. You weren't supposed to do anything, not to worry. Yeah, this is worth 100 points. No, okay, here we go. So if you have a piece of scratch paper, grab that out, and let's just play around with an idea of, let's say you're in a small park municipality, and you've got 3 or 4 little parks, and you've got a new GIS person, and you would like to start to manage this park using a GeoDatabase. So let's just play around with a schema, the things that we would want to capture and what that might look like. And just spend about 5 minutes or so on that, and then we'll talk about it.